We're Group 6. Today's February the 20th, and we were assigned problems 39, 79, and 115 on chapters 2.2. Here we're asked to solve 4 times the sine of 90 degrees minus 3 times tan at 180 degrees, leaving us 4 times 1 minus 3 times 0. 4 minus 0 equal 4.
For problem 79, you are given a point on the terminal side of angle theta and standard position is given. You're supposed to find the exact value of each of the 6 trigonometric functions of theta. So we were given the angle 2, negative 3. So we use the Pythagorean theorem, so r squared equals the square root 2 squared plus negative 3 squared. Then you would have 4 plus 9 all over the square root, which would equal r squared, and then r squared would equal square root of 13. And since you cannot break that down any further, your hypotenuse right at this triangle right here would indicate would be square root of 13. Negative 3 would be on y, and the 2 would be on the x. So for sine, you would do it like SOHCAHTOA, opposite over hypotenuse, which would be negative 3 over square root of 13. However, you cannot have a square root on the bottom, so you have to rationalize it by multiplying square root of 13 on both top and bottom, which then for sine you would have negative 3 square root 13 over 13. And for cosine it would be the same thing. Cosine would equal the adjacent over the hypotenuse, so it would equal 2 over square root of 13. But since we can't also have a square root of 13 on the bottom, we have to rationalize it, and at the end we would get 2 square root 13 over 13. For tangent, you would just have sine negative 3 and cosine negative 2, and you would have negative 3 over 2. Now for cosecant, you would just flip the sign of negative 3 over square root 13. So it would be negative square root 13 over 3. For secant, you would flip the cosine value. So it would be square root 13 over 2. And cotangent, you would just flip tangent. So negative 2 over 3.
Okay, so for number 115, basically you're just going to be punching in the theta values into your calculator for sine, and then you will get these according values. And then also for the sine of theta over theta, you will notice that the values slowly get closer to 1, while over here the values are going down.